Hello and welcome back to another episode of Math with Sohn, where today we're going to be doing conservation of momentum with collisions, and we're going to deal with how is it different if the collision is elastic versus inelastic, as well as dealing with some conservation of energy as well. So this first problem is going to be inelastic, and the big difference between inelastic and elastic is with it being inelastic, there is no conservation of kinetic energy, and if it's perfectly inelastic, both objects are going to be going in the same direction. So we have this 1,500 kilogram car moving at 20 meters per second, and it rear-ended this 1,000 kilogram car that was going 15 meters per second on ice, and they're going in the same direction. That on ice is because we don't want to deal with friction too much. All right, so when that happens, both cars move together immediately after the collision, and they are kind of like moving as one mass. So you got like one car, and then you got the other car. They're just bunched up next to each other after the collision, and they're squished, and they're moving together. All right, so that matters because with other collisions, they're moving in opposite directions. All right, so how are we going to deal with this? Well, for starters, we have to understand that the initial and the final momentum will have to be the same. So that means that initially we had this P1 plus P2 will have to equal the P both. So I'm going to explain what that means here. So we got the momentum of the first car and the momentum of the other car. They're going to be combined, and that would be equal to the momentum of both cars put together. All right, so the momentum of one car would be its mass times its velocity. So we'll call it m1 v1. The momentum of the second car would be the mass of its velocity. And then the momentum of both of them combined would be the mass of both put together times the velocity final. For both of them, technically, they would have the same velocity. All right, so let's solve for what we're looking for. We want to figure out what would be the, how fast are they moving after the collision? Well, we would have to divide by the mass of both. And then we would end up having our final velocity. So let's plug in everything. We got the mass of the first car, which is 1,500 kilograms. We got the velocity of the first car, which was 20 meters per second. And if we add that with the mass of the second car, which would be 1,000 kilograms, 1,000, and then the velocity of the second car, which would be 15 meters per second, we would need to divide that by the mass of both. Well, the mass of both would be 1,000 and 1,500 kilograms put together. Okay, so what would happen with that? Well, the kilograms, as far as like a unit, would cancel. And if we do the other math, you would have meters per second and meters per second. That's going to be the speed, the velocity final, and it is going to be, if we add them and multiply and do all the math, I already calculated it for us, 18 meters per second. Okay? Next one. Next one is going to be 2 blocks. Now this is edging towards purely going to be like an AP physics thing, where we are not going to have too much in terms of actual numbers. It's all going to be variables, which is a very big popular AP physics thing. But this one is going to be considered more of an elastic collision because they're going to be moving in opposite directions after the collision. We're going to figure out if it's actually elastic or inelastic afterwards. So what's happening here is a block with a mass of m travels at a speed of 4v to the right, and when it collides with another block of mass of 2m, it initially traveling v to the left. After the collision, the block of mass m moves to the left at v. That's a lot of words, so picture time. Picture time and scrap paper because we're gonna need it. We are gonna need it. All right, so we had 4v for this block, this cart, hitting this guy, which was traveling towards it at v. So when we have that, they go boom, and then they go in opposite directions. So originally this guy was moving to the right, and now it's moving to the left. And then originally the block with 2m was moving to the left, and now it's moving to the right. We want to find the final velocity of this 2m. And you could read through that and decipher it, but the picture is worth at least 100 words. It's supposed to be worth 1,000 words. All right, so what do we got here then? We have this idea that the PI plus, well, the initial will have to equal the final, all right? And what is the initial? Let's think about the initial. Well, initially, you had these two blocks moving towards each other, and now they're moving away from each other. So the first one would be mass times velocity for this first one would be m times 4v, and then the second one would be 2m, so I'm going to write 2m, and it's going to the left by v, so it would be negative v. So make sure you're paying attention to the fact that this is a vector. That is going to have to equal, we got the mass of the first one, which would be m times negative v, because it's going to the left. And then over here, that would have to be added for our final. We're doing the momentum of the final. So this would be 2m times vf. We don't know that final velocity there. So if we do some calculations, m is going to cancel on every single term. You could divide it away if you wanted to, or combine like terms without it. And then we have 4v with a negative v. That makes 3v equals negative v plus 2v final. Well, we're going to add v over. Oh, I forgot my 2. Oh no, this is not 3v. This is 4v plus minus 2v ends up being 2v equals negative v plus 2vf. Excuse me, see how I forgot the 2? It looked like I canceled the 2 out. Apologies. Add v over, you get 3v is equal to 2vf, which means 3 over 2v will equal the final velocity, which really means that the final velocity is 1.5 times more than original. All right? Not only that, but originally it was going to the left by v. Now it's going to the right by 3 over 2, or 1.5 times what that original was, to the right. All right? The next question is going to ask, let's find the paper, All right. Is the collision elastic or inelastic? Remember that it is 3 over 2 VF. That's the final. Okay, so in order to do that, I'm going to show you the answer key because it'd be a little quicker to write it, like just point. The K before would equal 1/2 mv squared plus 1/2 mv squared. Well, think of the two cars. We had the 4v and the v, negative v. So originally it was 1/2 m 4v squared and 1/2 2m negative v squared. And if you do that math, you get the before the collision is 9 mass times velocity squared. But then after the collision, we had it going to the left, and then the 3 over 2 that we just found. If we do the 1/2 mv squared and the 1/2 mv squared, if we combine the kinetic energy at the end, we find out that it's 11 over 4 mv squared. Well, I don't know about you. Last time I checked, 9 does not equal 11 over 4, and therefore the energy was not conserved. If kinetic energy is not conserved, then it is considered an inelastic collision. Regardless if they went in opposite directions, there must have been a sound, a big bang, or some friction, or something happened, some heat that was created, and we lost some kinetic energy along the way. Okay? So, I'm going to cut this one a little bit short. The next video we're going to talk about is going to be dealing with a pendulum question, and we're going to be finding the angle. So I look forward to seeing you then to wrap this unit up.